Welcome to Royal Research. When loading a massive list of data onto a web page, you've probably watched the entire application lock up and become unresponsive. This lag happens because the browser is forced to recalculate the size and position of every single element on the screen over and over again. In web development, we call this layout recalculation process a reflow. Today, we are going to write a highly optimized script in under 5 minutes that injects 100 new items into a page instantly, without a single stutter. Learning how to batch your changes and bypass these heavy browser reflows separates a novice coder from someone who can architect high-performance applications. Step 1 is setting up our environment. Open a blank HTML document and your code editor side by side. In your JavaScript file, write document.getElementById to target the specific empty unordered list element, the UL tag, that currently exists on your page. This diagram represents the Document Object Model, or DOM. Using an ID gives the browser the fastest route to isolate that specific node, without scanning the rest of the document. Next, define a variable and assign the document.createDocumentFragment method. Think of this fragment as an invisible container, existing completely in memory, outside the live document. By doing all of our construction work inside this detached zone, the browser has no reason to redraw the screen, saving crucial processing power. Now we need to generate our data. Create a standard for loop and set it to iterate exactly 100 times. Inside that loop, declare a variable and use the document.createElement method to generate a new list item node for every cycle. Apply your text and styling directly to these new nodes. Use the text content property for the text and ClassList.add to apply your CSS styles. Do not use inner HTML or apply inline styles here. Injecting raw HTML strings opens your application to security vulnerabilities like cross-site scripting, and inline styles force the browser to process formatting element by element instead of relying on a clean, centralized CSS file. Take your freshly styled list item and use append child to attach it to your detached fragment. At this exact point in the script, you have actively generated 100 new elements in memory, but because the fragment absorbs all of the assembly work, your live web page hasn't flickered once. Step 3 is the final assembly. Move your cursor completely outside of the for loop you just wrote. Call the append child method one last time. This time, attach the entire populated fragment directly to the empty list anchor you selected in step 1. The moment that single line of code executes, all 100 styled list items materialize instantly on the live web page. By moving the fully populated fragment in one single conclusive motion, you force the browser to process the layout and draw the pixels exactly once, rather than 100 separate times. Let's verify exactly what we just achieved. Open up your browser's developer tools and look at the performance profiler. This split-screen chart compares our work against standard methods. If you append items directly to the live page inside a loop, you get the chaotic, jagged line on the left. The browser is struggling to recalculate the layout every single time an item is added, creating dozens of sharp reflow spikes. On the right side, we see the results of our optimized method. The line remains smooth and flat during the loop process, concluding with only one clean rendering event at the very end, proving a massive reduction in the browser's computational load. The process relies on 4 steps: precise targeting of an anchor, creation of an off-screen fragment, batched wordification inside a loop, and a single final append action. Utilizing this strict memory management pattern guarantees lightning-fast rendering for any application as it scales. Thanks for joining us at Royal Research.